Large powers. De Moivre's theorem can be used to simplify the calculation of large powers of complex numbers. For example, express a half minus root 3 over 2i in the form or cos theta plus I sine theta. So what we're going to do is draw out our Argand diagram. Here's our real axis, here's our imaginary axis. And we're going to plot the point a half minus root 3 over 2i. So we go to a half on our real axis, the positive part of our real axis, which is about here. And we go to minus root 3i on our imaginary axis, which is about here. And we plot our point. So we plot our complex number. Next, we join the origin to our complex number. And what we're doing is forming the radius of the circle. And then we drop a perpendicular from the real axis straight down to the complex number. And what we're doing now is forming a right angle triangle. Where or, the radius of the circle, is now the hypotenuse of the triangle. And we're going to label the angle as the reference angle. And the adjacent to the angle will be a half. And the opposite to the angle will be root 3 over 2. So we're going to use this right angle triangle, and we're going to use Pythagoras' theorem to find the hypotenuse, which is the or. So or is equal to the square root of a half squared plus root 3 over 2 squared, which gives us 1. So the modulus is 1. Next we're going to use SOHCAHTOA, specifically TOA, to find the reference angle. So remember, this is the opposite, this is the adjacent of our reference angle. So TOA is tan equals opposite over adjacent. So tan of or, the reference angle, will be root 3 over 2 over a half, which gives us root 3. And the inverse function of tan of root 3 is 60, so the reference angle is 60 degrees. And we're in degree mode. So our reference angle is 60 degrees. Now, since our complex number, a half minus root 3 over 2i, is in the fourth quadrant, then we make our angle, our reference angle, be a minus. So we have theta equal to minus 60 degrees. So we're going to use our formula for KISS. So z equals or KISS theta. So a half minus root 3 over 2i equals 1, because that's the or. Cos minus 60 degrees plus I sine minus 60 degrees, which gives us KISS minus 60 degrees. Part 2, hence, which means using your answer from the previous section, express a half minus root 3 over 2i to the power of 10 in the form of a plus bi. So in part 1 we worked out that a half minus root 3 over 2i is equal to KISS of minus 60 degrees. So now we're going to put KISS minus 60 degrees, which we got from part 1, to the power of 10. Then using De Moivre's theorem, we're going to multiply the angle by the power. So we end up with KISS 10 times minus 60 degrees, which is minus 600 degrees. So KISS minus 600 degrees can be broken down to be cos minus 600 degrees plus I sine minus 600 degrees. And we know from property 2 that KISS minus A is equal to cos A minus I sine of A. So we end up with cos 600 degrees minus I sine 600 degrees. And using degree mode in our calculator, cos of 600 degrees is minus a half. And minus sine of 600 degrees is positive root 3 over 2, and we stick on an I. So just a reminder that the argument of a complex number, which is the angle that the complex number makes with the positive side of the real axis. So if our complex number lies in the first quadrant, then to get theta, we just get the reference angle. So we just use TOA. If our complex number lies in the second quadrant, then to get theta, our angle, it's going to be 180 degrees minus the reference angle. If our complex number lies in the third quadrant, to get theta, we will subtract our reference angle from 180 degrees and then stick a minus on. And if our complex number lies in the fourth quadrant, to get theta, we get our reference angle and we just stick a minus on in front.